I want to welcome everybody for coming today. We have a wonderful speaker set up for us, and her name is Sinduja Ramanujam. Ramanujam. And she
Yes.
is in the tech industry for 10 years. I'll let her say her name for you. For 10 years now in various roles. She's been an embedded engineer at Qualcomm, a kernel developer at Intel, a firmware developer at Intel, and a systems architect at Intel, and a senior project manager at Microsoft, before coming to become the technical PM at Meta, where she's focusing on bringing together the vision of Meta and the needs of the customers in ad ranking for Core ML. Sinduja coaches and helps PMs and aspiring PMs navigate the product manager world. She also firmly believes that being a product manager is an art, not a science. But with a few tools under your belt, she thinks you can create your own art. So she's going to be here to tell us about her work. She's also the mother of 4 and is expecting a new one in the world very soon. And so we're very happy that she could take this time to be with us today and talk about her career, how she got where she is right now, and what she loves to do. So with that, I will let you take it away.
Awesome. Thank you. Thank you, Jenna. Yeah, thank you guys. Thanks for taking the time out today to, dial in, be there in person. I couldn't be there in person also because what Jenna mentioned, I'm expecting a new one in like a few days actually. So hopefully things go well, but let's dive right in. I'm going to go ahead and present my screen. Let me know if you can see my screen. Let's see how that goes. Can you see my screen?
We can see your screen.
Okay, I'm gonna take that as a yes. I don't know why it's not switching my slide. All right, there you go. So yeah, today's topic is actually going to be more about ads at Meta. As Jenna mentioned, I am a product manager with Meta, a technical product manager actually. So what we do is at the cusp of both technology and product management. We do a lot of work with engineers. I interact a lot with research scientists, data engineers, etc. I'll talk a little bit more about that as we go. But for now, I don't know what's happening to my slide deck. If you guys can see my screen, I might just not bother skipping.
We can see your screen. Can you hear us? We got it.
I can hear you fine. Okay, let me just go through with this then. All right, so today's agenda, what we're going to talk about is, hey, what's an ad? The evolution of the ad industry. How has ads evolved inside Meta? So what does it mean for ads inside Meta? And how do we approach an ad across different products? And I will give you a very brief overview of, hey, how an ad reaches the device all the way from, advertiser putting it into the system to you actually opening up, say, Instagram or Facebook or whatever it is. And how do you see the ad? A very, very high level system architecture, not going into a lot of details there. And how Meta uses auctioning and pacing to be able to pick the right ad for the user and do the matching between, say, the advertiser and the user, etc. And what are the different teams involved, where me and my team help in this whole process. So that's the agenda for today. I do want to keep this as an interactive session, but I would appreciate if we can keep the Q&A towards the end. So I'll just go through the whole thing. There is a lot of ground that I want to cover. There's a lot of content that I want to share. But along the way, if there's some pressing question that you want to ask, please feel free to stop me. That's totally fine too. But I will reserve like last 10 to 15 minutes or whatever, however long we have left for Q&A. So with that, let's look at what's an ad. I would love it if this thing works. I don't know why this thing is not working for me. Come on. I'm going to try loading it again. I used to work for Microsoft before I became a PM at Meta. And so I do bet big on Microsoft, but I don't know if... All right, there you go. Awesome. Okay. So what's an ad? This is a vanilla explanation of an ad. You can go to Google, you can go to Bing, You can ask for what's an advertisement, and this is the definition that it's going to spit out. It's an advert, it's an ad, generally considered for public communication that promotes a product, blah, blah, blah. The textbook definition of an ad. But what an ad really is, right? All the way from the point of view of an advertiser to the point of view of a user who's looking at an ad. It's actually a story. And unless and until the ad is told in a story form, it doesn't reach the end user. It's an emotion that you're trying to convey. End of the day, what an ad is trying to do, or an industry is trying to do with an ad, is it's telling you what to do, what to buy, what not to buy, how to live, how not to live, and all the different things that's within the constraint of what an ad can communicate with you. And along the way, what the advertiser is also trying to figure out is their unique selling proposition or their unique value proposition, that towards the end of the day, if they were to kind of say, hey, you have a problem, and this is the problem that we are trying to solve in this unique way, how do they do it? Right? So behind the ad, there is a lot of work that's kind of going in before it reaches you. What I quickly want to do here is kind of take a step back. The way that we look at advertisements today is actually very different from the way that they have evolved over time. But the way that we look at advertisements today is also kind of fueled by the psychology and the economics that we've gathered, macro, micro, whatever economics that we've gathered over time to be able to do what we're able to do today. And the evolution started, I know I'm showing you pamphlets as the first evolution in like 1472, but it goes back even beyond that, is what Wikipedia tells me. So they have found tablets in Egyptian pyramids where it's a propaganda about the kingdom, why they're collecting taxes and what the tax will be used for, etc., right? In the end, trying to convince the taxpayer that their tax money is being used for good. Don't know why. It was a monarchy, so I have no idea why they had to convince anybody, but that's how it all started. 1472, we had written pamphlets where you could see people kind of hand out pamphlets on the roads, streets, put it up on billboards, whatever. 1704 is when the first newspaper ads kind of came out, evolved to billboard ads, which you still see existing today across many different developing countries. The first radio ad, 1922, and the first video ad on a television was 1941. This is where kind of things started moving away from like traditional advertisement to like digital advertising. And 1994 was when the first website ad was ever created, followed by 2004 when Facebook was launched. And you all would have seen that meme, all would have seen the joke where Mark says, hey, how do you make money? We run ads. So that's what we do. We run ads. And we have a bunch of platforms, a bunch of products that we develop and run ads across all of these different products. Moving on, switching gears to the various kinds of ads that we have inside Meta. There are 4 different kinds of ads we have. The first of it is image ads, where we drive people to destinations, websites, apps, through very high quality and engaging visuals. They can use their own images, or they can create an ad stock image. Recently, the generative AI, Dolly, and all of that coming in as well. What we've also learned is there is going to be a lot of innovation. There's going to be a lot of features that we're going to develop and push out the door very soon, where we're going to be able to develop these images using AI technology. Meta itself is an ML AI company first. So we use a lot of ML, we use a lot of AI, which I will go through when I go to the system design aspect of things. But before then, let's quickly look at all of the different types of ads we have. The second one's a video ad. You would have seen it as you keep scrolling through sponsored content. It shows off the product features, draws people's attention through sound and motion. And the third type is carousel, where you display up to 10 images or videos within a single ad. You can keep scrolling, look at the ads, click on any of the images. It will take you to either the of the product into the advertiser's website, or you will be able to convert within the product itself. Conversion means you're able to go from like clicking to actually buying the product in advertising terms, or at least inside Meta. And you have collection ads, where it's going to show you one product, but has a carousel to display other different products as well. So how do people get there from within the product itself, right? The first thing they do is they choose their placement, where they're able to say, oh, where do you want to choose it? Like, which product do you want to use to kind of show your ads off? Like this Facebook feed, there is Insta articles, and there is also a link that I've provided towards the end of this video. I'll also share a link with Jenna, I think, who'll be able to share a link to the deck itself. You can go look at all of the different ads we have. This is an external facing website. Where can you place an ad? What are the different products we have? What are the different services we have, etc. So as an advertiser, first off, you choose by choosing the placement of the ad. And then from there, you move on to say, okay, what's the objective, right? Kind of translating this into what I spoke about, like what is an ad? What are you trying to achieve by pushing an ad out? So what are you trying to achieve? Like why do you even care about this ad, right? Like, do you want to drive awareness to your product, traffic to your website, more engagement within your website? Are you trying to collect more email IDs so you can then create leads? Is it an app promotion? Are you trying to promote a product only, or are you trying to actually drive sales? So all of these different objectives, we look at it as user information, which is then kind of fed into models to then say, okay, what's the best placement? What's the best kind of ad? What's the best user to show this ad to, etc. So all of this is kind of set up as you go through the setup process. So you choose an objective, and then from there, you choose where to convert. So convert basically means it's kind of moving away from an intention of, hey, I want to buy this product, to actually buying the product. So where do you want to convert? You want to convert it in your website? Is there an app, messenger, WhatsApp calls, whatever it is? And then from there, we kind of say, what's the call to action for ads? So what do you want that button to say? From this, you are then given options to kind of create 4 different kind of ads. Image ads, video ads, carousel ads, and collection ads. Those are the 4 different kind of ads we have inside Meta. And all of these 4 different kinds of ads are available across all of the different family of products that Meta owns. Facebook, Instagram, Oculus, also introducing, because WhatsApp has kind of gone into like the business realm as well. There are ads inside WhatsApp which can also be utilized to kind of drive these awareness for your products, etc. So, okay, now let's kind of look at the system design or the life cycle of a digital ad, all the way from an advertiser putting in the ad to you receiving the ad within your product. This is the UI, or the user interface, where an advertiser is going to enter the ad details. I know it's not really legitimate, or like, you can't read the words, etc. That's for a reason. If you are interested in looking at the actual UI, you can check out Ads Manager by Facebook. There are lots of images, there are lots of videos on YouTube on how to set it up, etc. So you'll know exactly what the UI looks like. But in essence, what you're trying to do here, or an advertiser is trying to do here, is creating a campaign, a quote unquote campaign, to say, hey, I want to create an advertisement for my ad. And so this is the place where they're kind of putting in all of the different things we spoke about, their objectives, where do they want to convert, who is this advertisement meant for, is there a geospatial location, is there a gender preference, is there an age preference, what is the message going to say, how much are they willing to pay for every placement, how much are they willing to bid for every placement? So there is a lower bound, upper bound. And do they have a budget that they kind of want to stick to per month, etc. So all of this kind of goes into the actual algorithm of trying to figure out who the ad should be shown to, in what instance, and in what placement. I'll also talk to you about like the placement, bidding, pacing, and stuff like that. But one thing to remember is every placement has a particular value attached to it. So what that means is the first placement, or the first ad you see, is slightly higher priced when compared to, like, say, the 7th or the 8th or the 9th ad, because the number of people who kind of actually scroll through and look at those ads and interact with them kind of decreases as you keep going down. From there on, what then happens is it's kind of going into a database to store all of the different ads. So here we have a bunch of sharding, a bunch of dedupe, whatever, right, is happening so that we don't lose user information. But what we're also trying to do is we're trying to make sure that we are putting it into the right bucket so that when we do have to check for content sanity, when we do have to make sure there is no obscene content, there is no foul language being used, etc. All of that is kind of looking across all of these different DBs and making sure that the content that reaches the end user is actually of good quality. And this again is done by ML models. This is where the first ML models kind of kick in and they decide on what content to kind of not show and what content to show, etc., based on all the data that we've collected, trained the models, etc. And these models get trained approximately every 48 hours, give or take. It could be anywhere from 48 to 72 hours. So it doesn't get trained that frequently when compared to like all of the other models or the systems that you will see follow. Think about this as a system diagram. This is a user flow as well, but it's also what the back end is doing. And think about this as how or what it would take for an ad to kind of, for it to show up on your PC, on your phone, whatever it is when you load up the product for the first time. And then from there, what happens is it's kind of filtered it down. There is a new set of DB that kind of comes in and takes this content and stores it. All the safe content is stored. From there, what we do is, okay, now that, while creating the product, the advertisement, the advertiser has kind of given us a bunch of information, a bunch of keywords, right? So from this DB, it's then moved into databases or buckets or however you kind of want to think, where it's moved as per the ad's objective, the demographics, the age range, the location, etc. And how this is done is also done by ML models, where they're trained for across, again, 24 to 48 hours, but the soonest is 24 hours to train these models per objective. What happens then? Now let's kind of look at it. Okay, the top flows you saw all the way across is, think about it as an advertiser's flow. Now let's take a step back and look at it from the user's flow. A user has opened up a social media app for the first time, or like whenever, the first time of the day. Now there is a request that goes in. And what it's doing here is it's actually looking for, let me push my presentation up, just give me a second. Yeah. It's looking for user information, or it's actually storing the user information, privacy, compliance, hashed information. There is a lot. One thing that I do want to emphasize, which is kind of ignored when it comes to companies, social media companies like Meta, is there is a lot of emphasis on privacy, compliance, and what kind of user information are we able to store in these databases. Not everything can be stored in these databases. It is completely up to the user. They give consent to what we can store, and that's the only piece of information we can store. So whatever consent we're getting from the user are the information that's going into these databases, being privacy, security, legal, all compliance met, and it's hashed information. And we call it A&A, or aggregated and anonymized information, so that we're not able to tie it back to one certain user. There is no way to kind of say, okay, this information kind of came from Sinduja's phone if the user does not want to share that information. So, and then from here, again, these are all the ML models that decide which database should you go to, what information should be stored, what information should we throw away, etc. And these are also trained. This is where pretty frequently it starts, and they get trained every 12 hours. From here, there are other databases with user preferences, add information from the past that the user has interacted with. How did they interact with it? Did they convert? Did they just click? Did they even look at it? Did they scroll through? Everything else that needs to be kind of addressed for this aggregated anonymized user segment is kind of done. These are also ML models trained. This is actually wrong. It's not 24 hours. It's actually less than 12 hours. It's about 8 to 12 hours is when we train these databases. And then from here, now you would have realized that we have user information that's per segment, and we have advertiser information that's per advertisement. So now we join both the user and the advertisement information to say, okay, now what is the best ad to show this user? And this is kind of now going back to the user. This is where my team comes in. And we are the last mile system with super real-time information about the user same thing. It's very similar to these guys. And we train our models very, very frequently, around 10 to 20 minutes. An example of how I would explain this system, right? Think about it this way. If you were in the Bay Area, I don't know, I'm assuming I don't think anybody's in the Bay Area, but if you are in the Bay, and if you were in the Bay, like say on Monday or Tuesday, it was pouring cats and dogs. So you probably would have seen advertisements for umbrellas or rain boots or raincoats or whatever it is. Fast forward to Thursday, Friday, it's been pretty sunny for the last 2 days. If I showed you information about umbrellas, raincoats, it's probably not relevant to the user. I want to show you something else, maybe summer clothes or, like not winter wear and stuff like that. So how do I do that? I know I'm taking examples of like days, but we do this within minutes. We have real-time information where the models are trained to then say, hey, this system is telling me these are the best ads to show the user. You as the last mile, or you as a real-time system, what do you think? Is this something that we can even show the user? That's when we run our models and kind of apply a multiplier or a probability to say, how probable is this user going to convert? And if the probability is low, then we kind of ask this guy to go back and bring other ads so we can do the probability analysis all over again. And if it's pretty high, then we say, yep, looks good to me. Let's talk to the auction and the pacing models to see of these 10 ads, which ads go first, which ads go second, etc. And those guys give that information. That is then fed back to the database, which then pushes it out to the user. And that's what you see. All of this interaction is this, at least from the user social media app, talking to the user information, joining the information, etc., is happening in a matter of seconds, 3 to 5 seconds to be precise. And there is constant systems, computational analysis, and there is a lot of work happening to make the system even better, to be able to load this in like a few nanoseconds, a few milliseconds, if possible, etc. And there is a lot of study also that says that the faster you load the content, the happier the user is, and that kind of converts into them being more engaged with the app and everything else. So all those studies kind of go in to determine how efficient the system should be. And that can also give you a peek into the complexity of what we deal with, not just in a day in a day out basis, but I guess in seconds and seconds out basis. What do we use? Meta uses second price auction. You can read up all about second price auction. But what it essentially means is, for the winning bid, it's not going to take the amount of the winning bid, but it's going to take the amount of the second best bid that was bid for that particular position. So that's second best auction. So think about it this way, right? Like when the advertiser is creating an advertisement, they are saying how much they want to pay per ad, per impression, what their budget is for the day, for the week, for the month, etc., while they're creating that ad. What this kind of translates into is 3 things that's used to determine the winning bid. And everything is a bidding system in all the advertising social media apps you see. It could be Facebook, it could be Bing, it could be Google. Everything is bidding based. Meta uses second price auction. I'm not really sure what the other companies or what the industry standards are across it, but we use 3 things. We use the bidding amount, so the bid placed by the advertiser for that particular ad. We use the estimated action rates. So this is the probability that we would have collected across historical data of an ad similar to this. What was the estimated action rate for the demographic that this particular advertiser kind of wants to show, etc. So there is an estimated action rate for that. And then the ad quality itself. You would have seen, we filtered the obscene content, we filtered the foul languages, etc. That kind of attaches an ad quality number to it. And the measure of the quality also is going into the ML models to say, what is the winning bid? What's the winning auction? And as I already said, the ad placements are determined via second price auction, and every slot has a value. From what I remember, I think we fetch around 10 to 12 ads per second, put it on the cache, and use that information to kind of then flow it back to the user. And every ad from the first location to the 12th location has a value. And winner of that particular slot, whoever it is, pays the bid of the second highest bidder, and then so on. So the second bid pays the third bid pays the fourth, and we keep going that way. there are two things that is, or the way that we follow how this auctioning goes is also that the first highest preference is given to the end user. So there are three values that we consider. We said we're talking about like the user value. The user value basically means how useful is this ad to the end user while they load up, say, Facebook, Instagram, whatever it is. And that's the first priority. And that's what we always want to maximize for. The second preference kind of comes from the advertiser's standpoint of what is the probability that if I show this particular ad to this user, this advertiser is actually going to realize the conversion, right? That an actual purchase is going to happen against this advertisement. So that's the second biggest thing we consider. And the third thing we consider is actually revenue, where we say, okay, if this purchase were to happen, what's the revenue cut that Meta would get from this particular transaction? So that's the priority order as well. Again, my team kind of very much focuses on the third part of trying to optimize for the first, second, and is directly in line to make sure that the third part is also realized. So that's the last mile problem, right? Like, is it useful to the user? Is it useful to the advertiser? Is Meta not losing money on this particular deal and stuff like that? So we kind of tend to balance, or we have to balance all of these three things before we show the advertisement to the user. The second important concept while we pick these ads and show the user is actually called pacing. And Facebook kind of sets the bid for you in alignment with your strategy. Like whatever your ad strategy is, we kind of pick that up. So what that means is we can either raise or lower your bid for your particular ad. And we do it auction by auction basis. And not every auction that this particular this particular ad enters will it win. So which means we kind of also figure out which auction to enter, which auction to win, which position to show, etc. And that's kind of determined by two different pacing methodologies. One is bid pacing. So we adjust the bid based on the auctions you enter, the actions you want us to take, the demographics that's going to be part of this particular ad campaign, etc. And then the budget pacing. So we might increase or decrease your daily budget, keeping in mind what have you set as your monthly maximum. And then we optimize the events, or we try to optimize the events so that you have more opportunities for conversion. So two things that kind of play very much in is very important for our last mile problem is auctioning and also pacing. And those are completely different systems, completely different ML models, which also get trained every 10 to 20 minutes. This is the whole landscape of people who work on an ad. We have, from the tech and the engineering side, you have product managers, you have technical product managers, you have engineers, research scientists, data science, data engineering. Product managers kind of take care of the vision, the strategy, product marketing, most likely. Most of the times, technical product managers are very much responsible for product strategy, vision, but also the execution of it. So which means we work very closely with engineers, research scientists, data science, and engineering. So I'm a technical product manager with Meta. Product and user facing, you have product designers who design the actual UI you see. User researchers and content researchers as well, who talk to users, who talk to small businesses, who talk to advertisers directly to be able to say, okay, this is what I think the UI should look like, or this is what I think the user experience should look like, etc. And then you have marketing and sales. So you have product marketing, go-to-market, channel marketing, sales and field agents. All of these guys have to kind of come together, not every single day, but on a very, very regular basis, to be able to push out the code, to be able to push out the experiences that you see within the product every day. Where does my team fit in? As I said, so we are the last mile. So this is where I sit. This is where me and my team help. A few things that we do, right, is to make sure that we have excellent data quality when it comes to being able to say, okay, what are we training our models out of? So you would have heard this: garbage in, garbage out. So if we are not able to kind of keep a check on data quality to see what kind of data are we getting, what kind of data are we training our models on, then our output to say these are the ads to show the user is also going to be pretty bad. And that's going to kind of tank both Meta's revenue and also the user satisfaction. both the end user and the advertiser satisfaction is what I mean. So we need to be very, very cognizant of what kind of data comes in and how are we using that data. There is a lot of work that happens around data quality, data transformation, data consumption, etc. And I work very closely with all of these different teams upstream and downstream to be able to say, this is the kind of data we want to train on, and this data is garbage and stuff like that. We need real-time information to make the most informed decision. With real-time information also comes a lot of headache around what kind of real-time information do you need, right? So which means, again, it's about data and what kind of data do we have to consume to be able to make an informed decision. And because it's coming in real time, the systems, the reliability of it, the efficiency, how much can we go down, the maintenance, how long can we maintain, all of this also has to be taken into account. And again, we need to be cognizant of how much real-time information are we able to store. So there's storage, there's computation, all of those different beasts as well that we have to kind of tame and maintain. Many systems are involved to get the right data in. Yes, there is a lot of systems involved. It's very modular, so you can kind of pick one system, put another one in, etc. But what this also means that there is a lot of scope for breakage around the whole chain as well. So if one system is broken, then the whole system downstream and upstream are also kind of broken because they're not able to serve the end user the right way that they should. So we have backup plans, we have fallback, rollback, and all of those different jargons, methodologies that you would hear as well, which kind of goes into building the system the way it is today. And the system should be able to talk to each other, which means they also need to understand when they talk to each other. So what kind of data is coming in? What kind of data am I sending out? All of those different things. Storage computation we spoke about. And because we are the last mile, or we are the last line of defense before we show the ads to the user, we are also the first team that gets woken up if there is anything that's wrong with ads ranking. So 2 of our engineers are always on call when it comes to showing ads. And on call basically means you're on your, it's like a doctor being on call when you go into the emergency room and you have like somebody being there to attend to you. So you have 2 engineers always on call. If the system is down, they are woken up in the middle of the night as well to kind of be able to fix it, etc. And there is a product manager also who needs to jump in to understand what does it mean from a customer impact and kind of translate that to leadership and everything else as well. We don't own every single system you see. We only own the last mile system, which means we are also responsible for driving accountability, but doing it without authority. So this kind of falls more under the people skills, where you're able to say that, hey, this is your problem without actually being hostile about it, and being able to drive accountability. So that's really important. So all of these different problems we deal with, in addition to a lot of other on-call issues and a lot of other system issues and a lot of other data issues. And you know what is happening with Meta, like all the microeconomics and everything else. So this is what we do day in and day out when it comes to ads ranking. And this is what it takes to kind of show you one ad when you open up a product. So with that, I conclude my talk about ads at Meta. Thank you for listening. I'll open it up to Q&A. I'll stop sharing, but I'll open it up to Q&A.
Thank you so much for your talk. It was very interesting. And who in the audience might want to ask a question?
Hi, am I audible?
Yes, I can hear you.
Hi,
Soundarya.
hello. Thanks for the talk. It was great. I had a question on the next part of it. So I understood the part of how you drive the conversion of the clicks and how the entire process goes till the end user performs the transaction. But what happens after that? So if the user is not satisfied with the purchase, so how do you ensure that you have that information so that your model can predict better next time or something? So the next feedback loop, basically.
Yeah, that's a great question, actually. So there are 2 things that we do. The first thing is there is also a lot of information that... So, okay, before we get to that one, right? Once we are handing it off to the website owner, let's say, for example, you clicked on like a Nike shoe and you're not happy about it, etc. One thing that also happens is because we've handed it off to Nike, we are not able to pinpoint just that one particular transaction and say, hey, I don't think Shamdarya was happy with her Nike purchase. But what ends up happening is the next time we kind of do this ML model training, you would have already guessed this, that there is a lot of information that's coming in from previous transactions of users clicking conversion. But what we are also taking into account is if you go to a product today, there is an X out for the ads as well. So we also take into account how many X's have this particular product had before we kind of show you the ad, number one. Secondly, we also have third-party integrations into ratings, reviews, etc., which we kind of pull from the websites where we redirect you to as well. So that also kind of goes into determining what kind of ads we show. So which means if you as a user is not satisfied with a particular Nike purchase, and if you take the action to say, go and give bad feedback, or there's somebody else who's giving bad feedback about that particular product, that also kind of goes into training the ML model, and it learns to not show this particular ad to the user from that particular demographic. So that's the whole loop that we make sure that we kind of drive user satisfaction as well.
Thanks for that. I have a follow-up, if I can ask.
Yeah.
Okay. Suppose, so this was the user feedback loop. How do you get the feedback from, say, purchases which were made from the direct website and reviews which were written on the website? Do you monitor those reviews and based on that classify that this product shouldn't be shown in the advert because a lot of users don't like it?
There are APIs, there are third-party APIs that we have integrated, which kind of pulls in all of this information as well from like external websites. So there are ratings and review providers. So we don't have to collect information directly from Nike, say. Nike has a central database, SurveyMonkey. There are like other people as well who kind of have a database of these third-party reviews, which have third-party APIs, which we are then able to integrate, pull that information, distill it down to how the ML models can understand, and that also goes into determining what ads we show the user.
Okay. And how frequently does this happen?
So the ML models itself kind of get trained, I would say like every 48 hours, especially for trying to figure out, like, if you see the whole chain, right? Like if it's the first model you're talking about, it's somewhere around 48 to 72 hours. But if it's the last mile you're talking about, then it kind of does, like, it trains it every 10 to 20 minutes. But I think the database pull or the third-party integration pull probably happens like every few days, if not twice a week or something like that. So that's not that frequent.
Okay. Thanks. Thank you.
I have a question. Hi, I don't know if you can see me. I'm here in the room. So hi, Sinduja. This is Sindura speaking. So I'm going to take an opportunity.
Hey.
So I have a question more on the lines of, like, we've all read reports about how Apple's new privacy features has affected Meta's, ad revenues. And I keep reading news about how Google is going to stop using third-party cookies from 2024. And I see that, we're going to catch on to this train sooner than later. So I just want to know, from a more insight perspective, like, how does Meta plan to, readjust to these new changes, and what changes have already been done and are being currently done to make sure that, data privacy is taken more seriously, and the dependence on these third-party cookies and all of these is reduced?
Yeah, so I'll actually break it up into two things, right? I guess I'll talk about like what we've done so far, and I will talk about as much as I can about what we're going to do in the future without revealing too much information. So as I said, Meta takes like privacy very, very seriously. So what that means is we also make sure that we only collect the information that the user has given us consent to collect, if you will. So while you're going through your setup process or in your Apple account or whatever it is, and if you say, I don't want to share anything with Meta, then nothing comes to us, right? There is a way that Apple gives us information. It's called aggregated and anonymized, A&A for short. And that's a term that Apple has introduced, and that's how they want to kind of give us data. So what that basically means, I will not be able to kind of point back and say, this information came from Sindura. Instead, it's going to be like a bucket of information that says, oh, somebody like, people who are in this demographic who fall under this, I don't know, age range or whatever it is, might be interested in this product. So we don't even know if that click kind of made into them converting into a product and stuff like that. So we've had to be very proactive or reactive actually in trying to figure out like what ML models, how do we write it, kind of be able to say that, okay, we've lost the signal. How do we kind of now predict what the user is going to do, etc. So there's a lot of ML research happening in that particular area. Going forward, how are we kind of tackling that? There is, again, a lot of AI research. There is a team inside Meta called FAIR, where it's a lot about AI research, fast AI research or something like that, where we are trying to build models to be able to use these first-party data. So first-party data basically means data that Meta already has, right? And then build these robust MS models to be able to predict what the user wants rather than depending on the third-party cookies, third-party data, and everything else.
Yeah, that makes sense. Just to reiterate, like being someone who's actually interested in digital marketing, so I'm not like just going on the data privacy angle of it. I just want to understand, like, not having like individual level data on a person, what effect does it have to like digital marketing itself? Does it mean like it's going to affect, revenues for companies like Meta or Google who rely a lot on it, or they are actually
definitely
that don't affect?
Yeah, definitely. I mean, you would have seen like, I don't know if I mean, I don't know if you're following like the decline in revenue across Meta as well, right? There has been a lot of decline for revenue when it comes to like advertising. So advertising kind of encompasses 95% of where Meta is getting its revenue from, right? And the other 5% is kind of spread across like multiple other things, be it like Oculus, be it AR, VR, whatever it is, right? So with that being said, now that we've lost a lot of signals where we're able to like pinpoint and predict this is exactly what the user wants, we have lost revenue, significant revenue, over the last couple of fiscal years. So what that means you're able to see, right? Like I said, we're not able to keep up with the amount of salaries we've got to pay, the amount of people we've hired, etc. And that's resulting in like layoffs and everything else as well inside Meta. With that being said, what I do want to kind of reiterate is the research that's happening inside Meta to be able to say, how do we cope up with this particular situation, right? And that is where majority of the goodness is going to be coming from, is that because we don't have all the information that we did in the past, and we have this aggregated anonymized information, how do we kind of take that into account and say, this is what the user actually wants? And those are the ML models that we've built and we're trying to build going forward.
That makes sense. And I don't have a follow-up question, but we're a couple of us of you coming from like business analytics background. So it would felt really good to know how much ML is like, I mean, it's not surprising knowing how tech first Meta is, but it felt good to know how ML is an integral part of the entire process. And yeah, thanks for giving us some insights onto it. Thank you.
Yeah, of course. Yeah. I think Mark has hand up.
Okay.
Yeah, so I've been on excuse me, Facebook, and for a period of time, I'm liberal / progressive. So what has happened in the past is that I will get ads that are, let's say, conservative. I'm being euphemistic, right? Right. So there are things that are like, buy a Trump hat, or I'm anti-gun. They're like, buy, a new holster for your gun and stuff like that. So I have tried, and I've looked at the Meta, or I sort of, you have the ability, or you've given us the ability to go and look and see who they targeted, right? And so most of the time, it's like, if you're an American and you're a male, that's about it, right? They don't ask if you're liberal or conservative or anything like that.
Yep. So
I've painstakingly gone through and just blocked them, and for a period of time, they kept coming back. And then I would report them as offensive, because some of them are like really offensive to me. Okay.
Yep.
And eventually they stopped. So is that something you did to sort of have it figure out that I'm a liberal or progressive? Or
No,
did you
no. So what ends up
Yeah.
happening is we don't do anything to figure out if you're liberal or progressive or
Mhm,
what your affiliations are, etc. But what
mhm,
I really appreciate is what you kind of did to follow up, right? Is that
mhm,
you kind of said, hey, I don't appreciate looking at ads like this. And
mhm.
that information is what we call out as cross-out information or
Okay.
feedback loop, which is kind of then fed into these ML models,
Mhm,
which then figure out to say, okay, this particular region, this particular not user, but it's very vague where it's like
Sure.
hashed out information that says, okay, don't show these ads to say people in this region, or
Right.
don't show ads to like say people in this particular demographic or something like that.
Okay.
So that's how the ML models train with the data that's coming from the user as well.
Mhm. So you don't do anything like look at the things I like and say he seems to like these liberals or progressives. It doesn't.
No, nothing.
Okay. All right. Thank you.
That's the whole catch about like what Sindura was also asking is, now that you don't have all of this information, how do you predict, right? So that's the whole research that's also happening where there is a lot of, and that's the reason why you see the delay as well, where you've been doing it for like say a few weeks and then the thing takes effect, right? Because it's taking its own time to kind of train itself to then be able to.
Okay. All right. Thank you.
I think it was Mateo.
Yes, thank you. So I just had a quick question about for first I was wondering if it was important to have a lot of AI knowledge in order to become a product manager at a company like Meta. I was also wondering if you use technical skills as a technical PM and how much like compared to a normal PM, like how much technical skills do you use?
And so I'll take the first question first. So did I have any AI ML background before I went into Meta? The answer is no. I had a lot of tech backgrounds. I was a dev before I became a PM, etc. So technically, I have I've worked as a developer before I became a PM, but nothing to do with the AI ML space. But I, however, did a lot of reading on my own. Did a lot of digging around to just to figure out like what are the different types of ML models, how are they used, and of course, you wouldn't have outside information on what kind of ML models Meta uses until you get in, but you at least would know like what the life cycle of an ML model is, how does it get trained, etc. So all that superficial information I did have to research, I did have to learn. Technically, so again, there are two kinds of product managers, right? There's a tech PM and then there is a product or a non-tech PM. If you are a tech PM, you're expected to kind of understand how the system works, how the systems kind of interact with each other, what kind of data do you need to kind of make the system work, etc., etc. Also, because you're kind of going to be interacting directly with the engineers, so it's expected that you understand what it takes to kind of deliver a particular product and what are the requirements and how are you going to sequence them in a roadmap, etc. So you own the vision, you own the strategy, you also own the delivery of that particular idea, of the particular feature, whatever it is. In addition to that, you as a PM is expected to kind of understand what metrics you're collecting, how is it going to help the end user first, what problem are you trying to solve, and what does it mean to like, okay, data science, like how are you going to visualize this? So are you going to build dashboards? Are you going to have like config files, whatever it is, right? So that's kind of the end-to-end of what is expected from a tech PM.
Thank you very much.
Hazel?
Yeah, hi, Sinduja. So I had a question about the image ads that you mentioned. So like you talked about the generative AI technology and how you guys are working on developing products with DALL-E and Stable Diffusion and stuff like that. So I'm just kind of interested in how you think about the future of ads within Meta and how you think these personalizing curated ads can change the landscape compared to the regular online display ads.
Yeah, I think with the advent, like, as I said, like, Meta has been an AI ML company first. So which means there is already a lot of ML AI kind of happening and trying to figure out like, what to show the user, what is the placement, which ads, etc. is relevant to the user. But what we are also kind of venturing into is figuring out, there are 4 kinds of ads. There's video, there is image, there is carousel, there is collection. But you as a user, we also have, not you as a user, but then, like the hashed out information from the particular demographic, etc. We have that information of, does an image kind of make sense? Does a video kind of make sense? Does, like a mix of them make sense, etc. So we are also taking that information into consideration while presenting it, while presenting you with the ads, right? So that's one kind of how we are using AI. There is another way that we are also using is, hey, can we kind of take all of these different images and build a video if you as a user is more prone towards a video ad as against an image ad, right? And so how are we able to do that is, again, based on like all of these different AI technologies that have kind of come out. And even if we do not have a video ad on file for this particular advertiser, can we take the images and then build a video out of it, right? So those are the kind of information, or those are the kind of ads that we are kind of looking to build in the future.
Thank you.
Oh, that's also Hazel. Okay.
I
Sandhya, I think.
I had one question, just to follow up on that. Does that mean that you have early access to GPT-4, which can make videos?
We do not. Unfortunately, we do not. Well, I don't know. I don't know if I should say unfortunately or fortunately. But I don't think we have access. I mean, we have as much access. Microsoft has early access, I guess. We have as much access as anybody else in the industry does. Also because we haven't been like, I think, actively investing in GPT-4. I don't want to speak. Don't quote me on this, but I don't think we've been actively investing in OpenAI as much as Microsoft has been. But then I know internally we've been building a lot of all the AI ML models you see like that is predicting is all internally built, right? Like there's nothing that that's being outsourced and stuff like that. So those are the models that I'm talking about, but not interaction or integration with GPT-4.
Thank you.
Chaundarya?
Yeah. So I wanted to talk about the how the events actually get captured. So do you ensure, is there a fault tolerance mechanism or something like that which ensures that you don't lose the information when you're passing through so many different models before it actually reaches its end goal? So is how does the data streaming work? Because
Yes and no.
you talked about a lot of loops in the model. It's not like a straightforward architecture.
It's not.
So.
It's not.
Yeah.
Yes and no. So the architecture is actually a little bit more worse for wear than what you saw. Like it's a little bit more complicated as well. I kind of took a very eagle's eye view of it, right? So yes and no. There is a lot of fault tolerance that we have in place as well. But again, that's not to say that the data does not slip through the cracks, right? So there is, whenever there is an outage that happens, whenever the dev kind of gets woken up, the first thing we kind of also look for is what kind of information are we training the models on? Like how stale is the information, how reliable is the information, etc. So we have metrics in place that kind of measure if the data quality is up to the mark that we want it to be. So which means if it kind of goes above a certain threshold of data quality or below a certain threshold, above is fine, but below a certain threshold of data quality, we do kind of sound the alarm to stop and start throttling the data that we have in place to say, okay, the last 24 hours of data is actually garbage. Don't train the model on that, right? So there is a constant monitoring that's happening to make sure that we are training the models with the right data. And if we catch that the models or the snapshot that we have on file is not valid, then we roll back and say, okay, last 24 hours, just dump the data. So though there are instances where we've done that. We do that more frequently than not. So yeah.
But then that creates a lot of overhead also, which kind of cascades throughout the network if you keep
Yes, it does. Yes, it does. Yes and no, because I think, I'm saying 24 hours, which is like a long window, but we could determine like last hour, last 2 hours, whatever it is, right? Like the maximum that I think we've throttled has actually been 24 hours worth of data. But yeah, like there's like an hour, 2 hours, etc. So we just throw that data out, and then retrain the model whenever we have like solid information that we can retrain the model with.
So there is no kind of like a data streaming architecture which ensures like an external system or like systems which ensure that your data is always fresh. It's just a monitoring pipeline which runs and keeps checking. It's
Well,
not
we
in
make sure that the data is always fresh, but in addition to that, we also make sure that the data is valid information, right? There is a certain threshold or there is a certain quality to the data that we expect inside that whatever we get meets. So even if the data is fresh, doesn't mean it's the quality that we need,
and
right?
this
So it could
changes-
be latest information. Sorry, go ahead.
Oh, and this threshold changes across regions.
Exactly. And this threshold does change across like all of the different models, all of the different places within the system too.
Mhm.
Yep. Yep.
Cool. Thank you.
Yeah, especially for like the last mile, the threshold is very high when it comes to like data quality and like what do we actually take to train the data. And that's why I'm like, we can't just throw out 24 hours of data frequently. So we make sure that it's like, oh, last half an hour data. Okay, last 1 hour data, whatever.
Thank you.
Mark?
Yeah, so I just have one question, but if depending on your answer to this question, I have a follow-up question. Are there going to be ads in the metaverse?
You should ask the other Mark that question.
Okay, who's
I
the other?
meant Mark Zuckerberg.
Oh, okay.
I actually don't know the answer to that. I think metaverse as an idea is still getting flushed out, right?
Mhm.
And so if you ask me, are there going to be ads? I don't know. Maybe it depends on like user adoption, depending on advertiser adoption, depending on the market need, market fit, whatever, right? And many other things. So the answer is pretty unclear to all of us, even inside
Yeah.
Meta at this
I mean,
stage.
I gotta believe someone's gonna do it, right? I mean, someone's gonna create a space somewhere, and before you enter this space, they're gonna be like, see our wondrous whatever, real.
Yeah. No, I wouldn't be surprised if we introduced ads inside Metaverse.
Right.
And I mean, if the Metaverse is with Meta and if we introduce ads, I wouldn't be surprised. If Google goes for it, I wouldn't be surprised.
Right.
But what I'm trying to say is I don't think we have a strategy for advertising in Metaverse as
Right.
yet.
Yeah, because it's hard. Meaning, on Facebook, you scroll through your things and an ad is in between the stuff you see. You can't like look away. You have you do see it, whatever.
Yes.
In the metaverse, you're looking in different directions.
Yes.
And if there's an ad in, I don't think they want to have an ad that has when you turn your head, it follows you around. That would be annoying. But
Yes.
okay. All right. So, thank you.
Yeah.
Oh yeah. Hi Sinduja, great talk. So I just had a quick question. So we are all here students of I am from computer science. We have students from Questroom, business analytics, then also AI. So my question is, what would you recommend for students such like ourselves, who are going to be soon ready for the job market in this like market condition, basically?
Well, I don't know if I have an advice for myself.
Okay.
I mean, it's very uncertain, right? Like, honestly, because I had a conversation with my manager yesterday and I'm like, should I be worried? Should I be looking at it? He's like, dude, I don't know. So I guess it's very uncertain at this stage. But I think what's different from like, the previous 2008 market or whatever it is Meta is at a much more precarious or it's kind of at a crossroads because it's more macro and microeconomics for Meta. We're not getting data from Apple. Google is saying we won't give you third-party data, and the macroeconomics is also not helping out with like us having to like we've hired a lot of folks during the pandemic. Now we are like, oh, how do we kind of scale back? And that's the problem every other company like Google, Microsoft, everybody else is having as well. So I would say stay at it, I guess, and one thing that I've actually known that helps a lot is network. So if you are able to kind of tap into your network, be it through your internships, be it through other people you've met across the way during your during your tenure at BU. Reach out to them, have a conversation with them. Don't start it off with saying, hey, I want a job, but instead try and understand like which industry are they from, what are they doing, does it align with you, etc. And then have a conversation of, hey, can you introduce me to like somebody, can you recommend me, etc. And start early, start pretty early, right? Like don't wait for the threshold of saying, oh, 2 months out, I need a job now. If you have like another semester, maybe start networking now before you're actually ready for the job market.
Right. Thank you.
I guess that's, I mean, okay, now I know what advice I'm going to give myself. Fine.
Hi, Sinduja. My name is Siddharth. I'm a graduate student studying business analytics. So just bouncing off of Harsh's questions, for students like us who aspire to get into, product management, what are the skill sets or, the kind of business acumen that employers would like to see in potential candidates?
So when it comes to product management, very specifically, I think there are a few things that stands out when we talk to like a good PM, right? First of them being, do you understand the market? Do you understand what the users want? Which means, do you understand their needs, their pain points? And can you build a product to address that particular need and pain point? Translating that, again, do you understand the climate? Do you understand the condition? Do you know why you are building the product you're building? Do you know why the user is having that problem? Which means have you done competitive analysis and everything else, right? Like, so all of this put together, if you're able to bring this particular knowledge at the right time, I think that's what makes you as a PM stand out as against like, a normal PM who's like, oh, I understand everything, I can just go and execute, right? So that's what we look for. And even the PM interview process inside Meta is very much tuned to be like, okay, product sense, product execution, leadership, development. And in my case, I had to go through like 2 technical rounds as well. So yeah, that's pretty much what it boils down to.
Got it. Thank you.
So I had a question on the technical rounds. There's such a variety of technical, right? Are these technical rounds like someone asks you to code an algorithm? Because now with ChatGPT, I'm like, why in the world would anyone ask you to do a silly little Fibonacci set of code?
Yeah, nope.
What's the
point?
Yeah,
at least as a product manager, like you don't have to code, right? And honestly, that was one of the things that I did not really enjoy when I was a dev before I moved to being a PM. So you don't have to code, but the technical rounds kind of revolves around like system design. So they give you a problem and they ask you questions around things like, okay, if you were to design a, I don't know, like a Kindle for a blind person, what would the system design look like, right? So it's like a very vague, open-ended greenfield question. And because you are a PM and you're a TPM, what's expected of you is that you ask a bunch of questions around like the objective, the key results, what are you trying to achieve, what are the requirements, and then you kind of break it down to say, okay, this is what the system itself is going to look like, right? So those are the technical rounds that as a PM you technically go through. But other than that, like I've never had to code. The maximum I had to write code was probably SQL or Python, but Python has been very rare. SQL more so because you pull data, you want to look at user information, draw insights from it, etc. But other than that, I haven't had to code.
all right, cool. Do you have any questions for us? Oh, wait, there's one more. Sorry, we've got another question here. Here we go.
Okay.
Hi, I was just wondering, could you just give us your answer, how your thought process would be regarding how would you plan the Kindle for a blind person?
Wow, being her, are you?
I guess, okay, let's take a step back, right? Like, let's start from...
Yeah.
Sorry, can you say that again?
This is what you get when you come up with an interesting example.
I see. I should have probably zipped it, but okay. Okay, so I guess, as I said, like, let's start from the user, right? Like, I would probably ask you a bunch of questions about that user. Okay, when you say blind, like, are they fully blind? Like, are they partially blind? what does blind mean, right? And then from there, let's assume that you've said, oh, they're fully blind. So which means there are two options that you could kind of go with, right? Like the first one is it's either Braille. So are they able to read Braille, or do they need something that's going to like talk out to them? So which means, are they blind? Can they hear well? Which means if they don't hear well, then okay, then audio is out of question, right? It's probably Braille. If it's not Braille, like they can't read Braille, then you're kind of at a very precarious crossroads at the stage. You're like, okay, now then what? Like, why am I even building this app? Right. So you kind of take a step back at that point to say, okay, do I then have to think about something that's not conventional Kindle, right? Which means, is it going to be some sort of a device that, say, they attach to their head or something like that, which is going to send them brain waves that then lets you read? So maybe that's what you come up with, right? And then you say, okay, for me to build something like that, what are the different systems, or what are the different parts of the architecture that I have to think about? There is going to be a front end. There's going to be a back end. So in the front end, what are the different things that a blind person needs for this particular device to then attach to their head, say? And then for the back end, like, how do I upload a file? What format will that file get into? How will that format kind of change from, say, I don't know, PDF to brainwaves or something like that? I mean, you don't have to tell them what technology you're going to use, but then you kind of have to cover all of these different pieces to say, these are all the different things that I would consider when I build something for this person with these constraints. So that's how I would approach the problem.
Can I just follow up on that?
Sure.
So based off of that, I can see that, you have to come up with a broad concept, like a very abstract concept, obviously. But is it like would you recommend, with all of the questions and the information that you gather, you come up with a single solution? Or is it like you have some maybe 2 or 3 abstract possibilities that you can take the direction in? Like what exactly as a having person you're looking for?
So it's probably the latter than the former, right? I would expect that you come up with at least 2 or 3 different examples, at least 2, right? And then kind of weigh it out and say, and be very authoritative about, like, okay, this is what I want to build, and this is why, right? And then why needs to be pretty sound. And when I say pretty sound, we take into consideration things like return on investment. How much time, when I say return on investment being not just money, but also like developers' time, developer talent, whatever it is, right? That ROI. Second one being scalability. So I'm talking about brainwaves. I'm talking about like people blind. Can this be converted into something else that's not for blind people, right? Like, what is the total addressable market? So what's the scalability of this problem? So that's another angle to think about it. And then the third aspect is the uniqueness or the moat that you're creating with this product in the market. So has somebody else done this already? Are you just copying them? Or are you kind of coming up with a completely new product that hasn't even hit market yet? Right? So all of these different things need to be considered before you say, I want to do this for this reason.
Okay. Thank you.
You have anything else? Any other interview questions?
Did I get the job?
Yeah.
Exactly. You got the job. That is why you're here. And we thank you so much for coming. I see there's still a hand up. Is that?
Oh,
still-
yeah.
Well,
A very short question on that example that you mentioned right now. Why would I mean, if it's an app for Kindle, and if it's for a blind person who can't read Braille, then my personal gut instinct would be to say I wouldn't build Kindle, I would use Audible or something like that.
So I think we went through that also, right? That the person can't hear. What if they can't hear?
Yeah, so no, not just that. Like, I'm just saying, so if these were the constraints, then I would choose Audible. Or so why isn't suggesting an existing product and building on it better rather than just inventing something which is not in the market?
You absolutely can. That's totally up to you.
Okay, that is also okay.
Yeah, absolutely. I mean, so the reason why it's open-ended is it's completely up to you to figure out, like, how are you going to solve this problem, right? So there's no one right answer. So it's all you at this stage. All we are trying to do is saying, okay, can Chaundarya kind of figure out her way around this particular problem, and how does she do it?
Okay. Okay. So yeah, because the gut instinct first just reminds you of products which already exist in the market and build upon that instead of trying to just think of something new, right? So
Yep, absolutely, absolutely.
got it. Thanks.
All right, well, thank you so much for coming. I think everyone here would be like, let's give a round of applause here, and
Thank you.
thank you so much, and we will.
Congratulations and all the best.
Yes, exactly. We're
Best for
all
your
going to
childhood.
put in, exactly, good, you got good karma going on this one.
Yeah.
So we
Thank
wish,
you. Thank you so much.
thank you so much.
Awesome. Yeah. I guess you also know my LinkedIn profile, or you can ask Jenna. She knows my LinkedIn profile. So if you have any other actual questions that I can help answer, and if I can answer them, I will be happy to.
Very good. And I can share with you email addresses so that if you want to know the people who are reaching out to you as contacts, you will know that they came to you from our little group here.
Perfect. That would be awesome. That would be ideal. Yes.
Very good. Thank you so
Cool.
much.
Thank you. Thank you so much.
Thank you.
Bye.
Bye. Let me see. There we are.